Hey robot makers, hope you're having a good day so far. So do you want to learn how to use the Linux command line with a Raspberry Pi? Then this is the show for you. So let's dive straight in. My name's Kevin, come with me as we build robots, bring them to life with code and have a whole load of fun along the way. Okay, let's get over to our keynote and make a start. So yes, this is all about learning Linux command line. So we're going to go through some common commands if you're setting up a Raspberry Pi or just using it for day-to-day stuff, managing files and directories, managing how you install and remove software. We'll look at some system monitoring and management, checking how much free space you have and so on. And we'll look at some basics, networks, so you can get your IP address, things like that. And then finally we'll look at some scripting basics as well, how you can write some quite simple pieces of code using the command line and variables and so on. If you want to check out the course that goes along with this, it's completely free. Go to kezrobots.com/learn and then /linux_intro/. Everything I go through here today is covered on that course, and you can take it at your own pace. So let's crack on. So did you know Linux is 33 years old today? So yes, 25th of August 2024, Linux is 33 years old, and here's the fellow himself. This is Linus Torvalds, I think that's how you pronounce it. So he sent this message on the 25th of August 1991, so that was just about 3 years before I started studying computer science at university. So he said, hello everyone out there using Minix. Maybe we'll talk about Minix in a minute or two. I'm doing a free operating system, just a hobby, won't be anything professional and big like GNU. What's GNU, you might ask, for the 386 well, in brackets 486 AT clones. That's a type of IBM PC back in the day, or IBM compatible. And he says, this has been brewing since April and is starting to get ready. I'd like any feedback, like people like disliking Minix, any OS, as my OS resembles in somewhat physical layout of the file system, but due to practical reasons, among other things. I'm currently porting Bash, which is the terminal we'll be using today, and GCC, which is the GNU C compiler. And things seem to work. It implies that you'll get something practical within a few months, and I'd like to know what features people most likely want. Any suggestions are welcome, but I won't promise I'll implement them. And then you can see there is a Helsinki in Finland email address. And it says, PS, yes, it's free of any Minix code and has multi-threaded file system. It is not portable, uses 386 task switching, etc. and probably will never be, and probably never will support anything other than AT hard disks, as that's all I have. With the sad face. So that's what he sent 33 years ago. So it's come a long way since then. So let's dive straight into the command line and get up and running. I had a mini disaster just before this. Shall we just go over to there? Because I'd got everything set up and then I just managed to pull the cord out of the Raspberry Pi that I've got on my desk over here. So I've got a Raspberry Pi. This is the 2 gig version, which has just come out the last week. And if I go over to, in fact, jumping around to the wrong place here. Let me go over to here, which is, let's go for which view? That view, that's probably best. Okay, so I've got a Raspberry Pi here. I'm connected using the Raspberry Pi Connect service, which is like a free way of connecting to your Raspberry Pis over the internet. I find this is like really useful to use day to day. So that's the Pi that I've got next to me. So what we'll do, I'll just hide that for a second using the hide button on there. I've got a little Explorer kind of window open, a file manager window open just to the left, just so that we can see kind of what we're doing in the file system as we create files and edit them and move them around and so on. So if you want to open up the terminal, let me jump to the right place in my tutorial here. You can hit, I think it's Command, let me find it, Control plus Alt plus T on your terminal. So I can simply just hit this icon up here. You can also go to the Raspberry Pi menu, accessories, and find the terminal there. The only reason I'm not going to launch that one there is I've just zoomed in on this one, just so it's a little bit larger for you to see. So I'll just close that little one down, just for the sake of this tutorial. Right, so let's have a look around this terminal screen. So you can see there we've got this Kev at Raspberry Pi, and then we've got this little colon, a little tilde, and then a $sign. So this is known as the prompt. This is where we type our commands in and we get feedback directly into the terminal when programs run and we change things and so on. You can also see at the top of the terminal here, you've got Kev at Raspberry Pi. So it's mirroring what you can see on the prompt there. So Kev, that's me, I'm the user of this. That's my user account. And you can see the at, that just means I'm logged on to this computer, and the computer is called Raspberry Pi. I've not renamed this one yet. It'll be Devo5, I think, once I've got this up and running. So let's have a see what else we have. So yes, this is the sort of terminal output area. It's usually in lines. I think the default terminal is 24 lines like long and 80 characters wide, and that goes back to punch cards back in the day when they had like 80 columns or 40 columns. So there's a lot of history that goes into these things, and the terminal is kind of a throwback from when this was like Unix. This is based on, it's like a Unix-like operating system, and Unix operating system tended to have like one mainframe computer, and then you'd have a serial cable, just like we would do if we were programming our MicroPython devices, like a UART connection, and they would have a dumb terminal, a keyboard, and possibly just like a printer, and then later on it became like a display. And then even later on you would have like a graphics display and a mouse as well. But yeah, the terminal we're using is sort of harks back to those very early mainframe kind of days, but it's very powerful, and the reason it stuck around is because it just does work. So that's simply opening up our terminal. So let's get started with learning how to type stuff in. So this is where you do have to retain some of the commands, because without knowledge of these commands you'll be stuck, you won't know what to do. So one of the first things I want to type in is man. This is the manual for commands. So one of the commands we're going to look at in a second is called ls, which is like the list command. So if I type man space ls, it will then open up the manual for the ls command, the list command, list directory. And you can use the arrow keys on your keyboard to move up and down and read all about this. You can use the page up, page down to get all the information you need. And you can see there's lots of different parameters that we can type in to make this ls command work. Once we're happy, we're finished with this, we can simply press Q to exit man. So man is quite a useful thing. You can even do man, which will give you the manual, how to use manual itself. So I quite like this. It's kind of like a help system. You can even type in help, and that'll give you a list of the most common commands, kind of a short version of that. Now man can do a lot more than this. If you want to know, is there a man command for, let's say, directory, you want to know about directories, if I type in man space -k, that will be the keyword search. So if I press return, any man page that has the word directory in it now appears on the screen, so we can see them there. We can scroll up and scroll down on our terminal to see all of them if we want to, and how many times that word appears as well is sort of in brackets. So that's quite useful for searching for commands if you're not familiar with how to get up and running with the various commands. Okay, so let me see what we're up to now. So next up, we're going to look at how we move around the file system. So in Windows, on Macs and on PC, Windows, Macs and other graphical user interfaces, you tend to have this kind of view of the world. So you've got some kind of file system manager. You can navigate all the different folders using these little disclosure triangles. But how do we do that in Linux? How do we actually navigate the file system? And how did people do this like back in the day before we had graphical user interfaces? So we've got this idea of tree. So there's a tree of all your different folders and files. And one of the concepts in Unix is everything is a file. So the graphics display is a file. Folders are actually just files that contain other files. So everything is a file. So because of that, that makes working with files a lot easier, because everything is just treated exactly the same. Even devices, even printers, everything, Bluetooth connections, they're all just treated as a file. So we just need to know how to maneuver around the file system. So if we jump back to the root, I'm going to use this cd command, and we'll talk about this in a second. So I'm going to do cd space /. That's going to take me to the very root of the file system. And I can use the ls command to list what's in that file system, what's in that current directory that we're working in, which is now the root. And you can see that we've got a couple of different folders. We've got bin, we've got dev, we've got home, lost and found, mnt, which stands for mount, proc, which is to do with processes which are currently running. We've got run, we've got server, we've got tmp, temp, where temporary files are stored. We've also got var, which is like a variable area, which is quite similar to temp, but this is for things that are running at the moment and need just a temporary working space. We've then got boot, which is where all our boot files will be stored when we boot up the computer. Got etc, etc. This is all the other stuff that nobody knows where to put, so they put it in there. We've got lib, which is our libraries of all different extra bits of software that we might need to use on our computer. We've then got media, so this is when you mount a USB file system, for example, that can appear in the media folder. Back in the days when you had like CD-ROMs, they would appear in the media. Then we've got opt, which is like optional software. Root is the root user. So the root user is the sort of super user of the computer. Every other account is just like a regular account and can't do specific things like format the hard drive, for example. You have to be a super user, a root for that. Then we've got sbin, which is the super binaries. So bin was the binaries folder at the beginning there. We've got sys for some system files, and we've got user, which is where a lot of the user accounts are managed. So let us have a look at how do we know where we are in the file system. So we use the pwd command, and that will say print working directory. So we're currently in root. Now I'm using this ls command to list files to see what is available to me in this particular working directory. So the ls command looks like this. If you've got a color terminal, you'll see the colors enabled there. Sometimes it just appears in black and white, but the colors kind of help you understand what kind of file they are, because there's some intelligence behind that. Now that's a very simplified view. We can actually do ls space -l for the long view, and that will give us a lot more information about the files and folders that we can see there. So you can see these very esoteric looking DRX, RX, RWX repeated. We'll look at those in a minute. They're actually file permissions. Then we've got the number of is that number of bytes? We've got an indicator there. We've got root and root. So there's like who is the owner of this file and who is the group that they belong to. And then we've got the number of bytes that are being used by this particular, or blocks. These are not bytes yet. These are blocks. I'll show you how to turn it into a human readable megabytes, gigabytes, terabytes, and so on. Then we've got a date when the file was created, as well as the time, and then the name of the file itself. Now sometimes you'll see that it's got this dash arrow, and that means that this is a link. This is like a shortcut to a different place. So you can create shortcuts to files just like you can in other modern computer systems. So it's just a way of keeping the naming consistent, but actually pointing it to a different location. So that is the ls-l. Now if we want to go into a folder, we change the working directory. We do cd and then the name of the folder we want to go into. So I'm in the root. I'm going to go into home, and then I'm going to do an ls-l to see what else we have in here. So we've got two users. We've got Alex and we have Kev. So I'm going to go into cd kev, which is my home folder. If I do an ls now, you can see we have, or ls-l, we can see we've got a couple of different folders. So we've got bookshelf, clustered pie, which is something I've downloaded today. We've got desktop, which is where a lot of these files on the left hand side will appear. We've got documents, downloads. So when you're working with like a browser, when you download files, they appear in the downloads folder. I pulled down this dummies.txt so we can have a look at this in a minute. It's just a text file. We've got music, which is where music will get saved. Pictures, if you take pictures with a camera, they can get saved to there. Public, if you're creating like websites and things, or you want to share files with people, this is where you would do this. You would drop it into the public folder, but that's more sharing on a local area network or just within this computer, and lots of people log in at the same time. I've then got some other files. I've got pytest.py, some text.txt, templates and videos, and they're just other folders that we can use. So if I now do cd and then documents, if I just type the first couple of letters of that and then press the tab key, it will auto-complete the rest of that name for me. Now sometimes if you just type in, say, do, there is two different things that it could pick from there, documents or downloads. If I press tab, it won't do anything. If I press tab again, it will then suggest that there's documents or downloads. So I can just press the next character and then tab, and it will auto-complete that. So if I press return, we're now in that documents folder. You can see now that the prompt has got documents there as well. So that tells us that we're in the documents folder. Now, there are some other shortcuts we can use when we want to change directory. So if we do cd and then $, and then in all uppercase, home, that will take us back to our home folder. We can use that pwd to check that the home folder, where actually are we in the file system. So /home/kev, my user is Kev that I'm logged in with, so that's my home folder, that's where all my files will live. We can just do an ls, you can see where we are again. Now if we want to back up a folder, if we want to go step backwards, so if I go into that documents folder and I want to come back out of that, I can do cd space ... and that will take me up a level. So in Unix you have this sort of weird locational thing. So if you do cd dot, that's the current working directory, whereas cd ... is the one before that, lower in the tree. So if I do pwd, you can now see that we're in home, so I can go back into cd kev and we're back in our home folder again. Now when you're navigating, you can also navigate by absolute paths, or you can navigate by relative paths. So absolute paths start from the home, from the root folder. So if I wanted to go into the documents folder, I could do cd, the root, which is /, then home, then /kev, then /documents, and it will take me to that path. And I provided the entire path there for it to go into. So that's an absolute path. I jump back one, whereas if I do cd documents, I'm not providing the entire path, I'm providing a relative path because it's relative to where I am now. So by doing that, it takes me into that same location. So there are two different ways of finding where your files are. It's easier, I think, to work in the relative way, but sometimes when you're writing a script, you don't know where that script is going to start from, so you might want to actually write in full absolute paths for that. Cool, so that's how we can navigate up and down the tree and have a look at what the files are there. Now if we want to clear the screen, we want to clear out all this stuff that's on there, we can simply just type in clear and it will just refresh the screen, and we've just got that nice clean terminal with the command, the last thing that we typed in there. Now if we want to see a history of all the commands that we've typed in to date, we can simply type in history and it will give us a list of all the things that we've typed in since we've started on here. So you can see there's probably some other things that I've typed in there before this terminal even opened. So it's history that will span all the different sessions that we've had there. So quite a useful one. Now we can actually run a command. So if I wanted to type in, say, that pwd command, I can see that's command number 134. If I do !134 and then press return, it'll run that command. And if I press the up key on my keyboard, because I'm using bash, it's got this really nice kind of autocomplete function, and it has all the history, and when you press the up key, it's essentially going up and down that list. So as I press down, it'll go to the very bottom, as I press up, it'll go and go through all those different histories. So it's really useful to have that command history, and you'll find a lot of people, rather than typing out the command, they'll just press the up arrow a couple of times to get to where they need to, like that. Okay, the other thing you can do, if you want to, say you have a command and you forgot to type in, no, you want to run the very last command you did, you can type in !! The last one I typed in was clear. So if I just type in like pwd, and then I do ! It'll then show you what I've just typed in, which is the pwd command. So these are quite useful to sort of remember when you're working with a terminal. Okay, next up. So before I was talking about different levels of permission, and we have this sort of super user that exists, the root user. So I'm logged in as Kev. I've got limited permissions. If I want to do some funky things on here that might destroy or damage my computer, or would step into somebody else's area, I might not have permission to do that. So we want a super user who can override all these things and do things like create users, delete users, and we don't want everybody being able to do that. Imagine you're in like a college environment, a school, and you want to give people accounts. You don't want them changing each other's passwords, deleting their accounts, deleting their files. You want to be able to sort of separate all these accounts out and have them so that they can just be managing their own files. So if you want to be the administrator, the super user, there is a command that we can type in which is called sudo. So sudo stands for super user do, and it's just a way of elevating your privileges for that one command, and then it drops it down back after that. So if we want to do something like, let's say we want to update, we'll go into this in a second, we want to update all the packages that are on our system. If I type in apt update, we'll talk about APTs in a minute. You can see there when I type in apt update, it says couldn't open locked file, unable to open locked directory, problem unlinking the file, permission denied. And that's because I don't have, as a regular user, permission to update the packages. If I run the sudo and then apt update, it will happily run that command because it's the super user account. And I've added my Kev account when the Raspberry Pi was being very first set up. My account was created with that extra level of permission. So if I log in as somebody else, they are not able to run the sudo command. Only sudoers can do this. So again, that's something that you'll set up. Now you might think, well, why don't you just log in as root and then you've got admin access to everything you need to do? But there's a couple of reasons for that. One is safety. So the sudo command helps prevent mistakes because you're only using that special permissions when you need it. So you're not going to accidentally do things that you shouldn't do because you've got those permissions all the time. Security, it keeps track. So the Linux system keeps track of commands that have been used with a sudo. So you can see who's done what on the system, who's used elevated privileges for what. Whereas if they all use the one root account, you would not know because, you know, it just shows up as root. And then there's a control element to this because you can decide which users are allowed to use the sudo command and which are not. So if you run like a faculty, you might have quite a few super users, whereas if it's just your computer, you probably have that as well, just for yourself. So one of the things we might want to do then is we want to create new users on our system. So if we do sudo add user, and then we think of a name. So if I do, I don't know, Jenny, for example, it'll then create a new account for Jenny. So it's creating this in the group 1002, adding the user Jenny 1002. That's just like a number it's given it. And it's creating a new home directory. So that home folder in before, which had Kev and Alex, will now have Jenny as well. And it's copying files from /etc/skell, which is like a skeleton folder system. It'll have all like the documents, desktop downloads, all those things that we saw in my account before. Now we can set up a password. So if I just set up a quick password there, and then we can even type in more information as well. There we go, Jenny Mac, and then room number 101. You can put all kinds of information here, or you can just hit return. And then you can just say, yes, that's all good. And now, if I do ls/home, we can see now that there's a Jenny folder there as well. If we try and look inside that Jenny folder, it says I've not got permission to look inside Jenny's folders because that's her account and that's where her files are stored. So even with me as the main user of this computer, I've not got permission to do that. If I was to run that command with sudo, it would then show me what's in there. Nothing's in there at the moment, but I didn't know that without running the super user command. So if I do that, it'll just say permission denied. Now if I want to delete a user, I can do sudo del user, and I can type in, let's delete the Alex user, for example. And it says it's removing the cron tab, which is how it schedules tasks. It's removing the user Alex. But an interesting thing is if I do ls home, Alex's home folder is still there because it didn't delete that when it deleted the user account. So there's kind of stuff left over there. And you might want that or you might not. So if we add back in the Alex user, let's just do a sudo add user Alex. And we just type in another password there, just press return for everything. And then if I delete Alex and then do -- remove home and then the Alex, it will have actually removed the home folder this time. So if we now do ls home, you can now see it's just Jenny and Kev accounts on the system and no home folders reside for Alex. Now we might want to give people the super user permission. So say Jenny is somebody we trust and we want to give them permission to do extra things on the computer. We can do sudo user mod. So we're going to modify our user account. We're going to do -- add to the group. So lowercase a, capital G, sudo, and then Jenny, like so. And Jenny's now been added to that sudo as group, and that means you can do things such as creating further users, for example. Now, what about passwords? If I want to reset my own password, or Jenny's password, or Alex's password, whoever's on the system, we can use the password. So it's like password, but the O and the R in there, passwd. So if I just press that on myself, it'll just say what's the current password, and I can type that in. If I just type that wrong, it'll just say you've done that wrongly. But I can also do password Jenny, like so. In fact, I have to do sudo, sorry. And I can now give Jenny a new password. So if I just type in that, she's now got a new password. I can also do things like expire Jenny's password. So if she's come in and phoned up the help desk, if you're working like an IT faculty, she might say, I forgot my password. So rather than typing a new password in for the user that's phoned up, you can just expire their password, and it'll just tell them to change it on the next time they log in. I mean, I guess that wouldn't work if they forgot the password, but if you want to basically expire the password and force them to reset it on the next boot, the next login, then you can use the -E, and that will have the effect of making them expire their passwords. If I do that, Jenny's password now be changed, and she'll be asked to log in and change her password on that first login. Okay, what else we would need to look at on here? So we can look at groups. So if you have lots of different user accounts, there's a point where they become kind of unmanageable, and if you wanted to give everyone access to a particular file, it'd be a lot easier to do that once if they were all member of a particular group. So you might have like I don't know, a computer club, and you might create a computer club group and then add all the different accounts that want to use that that group. So the way that we do that, we do sudo group add, and then the name of the group. So I'll say code club could be the name of the group. So we've now got a new group, and we might want to add people to that. So let's just create the Alex user again. So I'll do sudo add user Alex, and let me then we want to modify the group. So let's do sudo user mod. So I'm going to modify which group. I'm going to add to the group code club, and then we're going to add Alex in there. We can also add Jenny in there, and we can have Kevin in there as well. So now we're all part of that same group, so we can actually set permissions on folders and files just using that group membership, and then everybody that's in that group will therefore be able to read that the contents and change them. And we'll look at permissions in a second as well. And to delete groups, we use the sudo del. To delete users, we use del user. Let me say that again. To delete a user from a group, we use del user, and then the username. So I'll say Alex, and then the group name, so code club. And that will remove Alex from that particular group. So only Kev and Jenna are now a member of that. If you want to see where all these groups are and so on, there's quite an easy way you can do that if you're a super user. You can do sudo, and we'll look at the cat command in a bit later on, but if you do sudo cat, etc., and then the password file, you can see on there we've got Kev, Jenny, and Alex. You can see that there's lots of other accounts on here. There's even an account called nobody, non-existent, no login, so we prevent people from automatically logging in with anonymous accounts on here. But you can see that, yeah, the different things that people added to there. I think there's also a groups one. Is it group? There we go. So Code Club has currently got Jenny and Kev in there, and the group number is 1003. So there we go. You can see we've got Kev, Jen, and Alex accounts in there too. Okay, let's go over to working with files. So I realise I should have pressed my back to here for a second. Let's just do that once. Yes, if you want me to make more of these kinds of videos and you want to help me do that, one easy way to do that is drop the video a like. So if you've not done that already, please consider doing that. Oops. And also consider dropping me a comment and subscribing. And I do go live every single Sunday at 7 o'clock British Summer Time or GMT, depending what time of year we're in. So you can certainly drop into the live stream and have a bit of a hangout once the main show is over. Cool. So yes, managing files. Let's get back to managing files. Okay. So what we want to look at now is how we can create files, how we can look into files, how we can look at top and bottom of the files, and also edit files. So let's have a look at that now. So the first thing we want to do, and this is why I've got this this folder open here. Let's go into Kev. So I'm in my documents folder. I'm just going to cd ... out of that. So I'm now in the same folder as you can see on the left hand side. Now if I want to create a new empty file, I can do that using the touch command. So if I say touch and let's say example.txt for an example text file, you can see there on the folder we've now got this example.txt, and I can even double click that on the Raspberry Pi user interface. But if we were just using the pure command line, how can we actually see what is the contents of that file? So we can use the cat command. So this is like catalog. It's a way of looking into what is in a particular file. So if I do the example.txt, there's nothing in there, so we're not going to see any content. But if I do something like the Dummies Guide to the Internet, this is a huge file. This is part of the Project Gutenberg, which is a free text files. So you can see there it's absolutely massive. So it's not very easy to read through that. So one of the things that we can do on here is we can view it page by page. We can use the less command. So if I type in less and then dummies, I can now use the keys on my keyboard to scroll up and down, or do the page up and down, and be able to sort of scroll through. So there you go, the Big Dummies Guide to the Internet version 2.2 Electronic Frontier Foundation. So there you go. So that's the way that you can navigate that. You can press Q to quit and come out of less. If you just want to see the top of the file, you can type in head and you'll get just the head of the file. So there we go. So that's the first, I think, 10 lines of that particular thing. And if there's a head, there is also a tail, which will show us the bottom of that file. So that's just some license agreement thing on there. So there we go. That's that head and tails. Now that's great if you just want to see the contents of the file, but what if you want to actually edit it? We'll have a look at this in a bit more detail in a minute, but there is a really nice editor that comes with Raspberry Pi OS that's called Nano. So if we do Nano and then dummies.txt, you can see there we've got like a full text editor. We can go in there and we can actually add content. So I'm going to say add content, and I can save and exit that. I'll show you this in more detail later on. I'm not going to save that. Okay. So next up is working with directories. So you've seen these, they call them directories on Linux. You might know them as folders everywhere else. So these yellow things that we put our files in are called directories in Linux. So we can use a couple of different commands to view the directories. We can do ls, and then I think it is ls / star. No, that's not it. Yeah, I basically just want to get a list of the directories. So we do vdir, you can see there, it's essentially just the ls command -l, it's the same thing but without the colours. And we can see that all the blue ones, anything that has the D as the very first character in the permissions, indicates this is a directory and not a file. So that's why we know that they are directories and not files. Now, what if we want to create our own directory? So we want a projects folder where we're going to create some code for a project we're going to be working on. So we can use the mk, which is make dir, make directory. So mkdir and then projects. Now, one thing about Unix-like systems, they are case sensitive. So if I do make projects and projects, they look exactly the same, but one's got a capital P and one's got a lowercase p. That can really throw you off if you're working with case sensitive file systems. I think by default on macOS they have a case insensitive file system, so you can type either and it'll be fine. I think Windows is also similar. So now that we've got two, how do we want to remove that directory? So it's simply just rmdir. So let's get rid of the lowercase one. I'm just pressing tab there. So you can see now that lowercase one is gone. We've still got this nice one here. that we can navigate to and do things with. Now let's copy, I'm just going to do this so that we have something inside that projects folder, and we'll look at how to do this on the command line in a second. So I've copied that Internet Guide for Dummies into our projects folder. So if I now try and remove the projects folder, it's going to say it failed to remove it because it's not empty, there's stuff in there. So how do we remove the entire folder system without caring what's in there? So we can simply do rm-r to recursively delete things, and then projects. And now that's got rid of our projects folder and everything that was in it as well. So it's quite a dangerous command if you do that by accident. So next up, we want to copy files around. So if we want to copy our dummies.txt, we use the CP. So this is short for copy. It used to be like copy in DOS, I remember, but CP is what we have in Unix. So if we do dummies.txt, and we might want to call this dummies copy.txt. So you can now see we've got a copy of that as well. So that's now taking up more space. It's not intelligent enough to create like a copy of that without taking up extra space. I think modern file systems like on Windows and Mac OS, they're intelligent enough to know if you copy a file and you don't change the contents, it doesn't actually take any extra space upon disk until you start changing one of the copies. So that's called copy on write, but we don't have that on the ext file system as far as I'm aware. So we can also copy entire folder systems. So let's create that projects folder again. And let's put that dummies.txt inside that projects folder again. We just do that, put it in there. In fact, we can type this on the command line. Now we know how to do copy, so we can say copy dummies.txt into the projects folder. Like so, dummies.txt, sorry. Right, so if we go into that projects folder, we can see that we've got a dummies.txt in there. So if we want to copy like an entire folder, we can just use the copy command, and we can do recursively copy it. So -r projects, and we can say projects backup, something like that. So we've now got a projects backup, and that's also got a new copy of that dummies.txt. And if that had like other folders and other folders and other folders deep, it would copy all those as well because it's recursive. It'll go through them all. Now, how do we move files and how do we rename them? Well, in Unix, it's actually the same command. It's the move command, the mv command. Oops. So if we want to rename that project's backup to be something like project's backup and then maybe a date. So let's do 25-08-2024. Oops, I need to say where it's going from and where it's going to. Sorry, I missed that one out. So projects backup. So I'm going to move the projects backup. I'm going to rename it essentially to the projects backup 2024. So you can see now we don't have the projects backup now. We've got projects backup 25-08-2024. So that's a way of renaming things. And similarly, if we want to move a file in its entirety, if we just do move the dummies copy, and we want to put that into our projects folder, we can do that. And now we can see that the dummies copy has now gone into our projects folder. So you've got two files there, the dummies and the dummies copy. So move is a very simple command to use, and it's a really quick way. You saw how quick and responsive it is, because really all it's doing is updating the directory entry for it. It doesn't actually have to move the contents of the file in its entirety. So that's quite neat. And then if we want to remove a file, we want to get rid of some stuff, let's go into that projects folder. We simply use the rm command. This is remove. So if we do remove dummies.txt and remove dummies copy, we can see now that they've disappeared from there and no longer exist. So there we go. So we've got make directory, we've got remove directory, the remove recursively, copy command, move command, remove command. We also have that verbose directory list in the VDIR, which I don't think is used very much nowadays. Okay, so next up, what I'm going to do now, because it's a bit easier to show you this rather than sort of talk about it, I'm going to jump over to the course that I created for this. So The next step after working with directories is files and permissions and ownership. So it only takes 5 minutes to go through this. So we've got two commands that we need to use to change permissions and ownership. We have the chmod, which is the change mode, and we have change ownership, chown. I always think it looks like clown, chown. And we've got three different types of permission that we can have in files in Unix. We have the read command, we have the write command, and we have the execute command. And we can use these in different combinations to create interesting folder systems. So for example, if we wanted like a Dropbox, think like a ballot box where you can put something in, but you can't see inside that once you put something in. You can create a write and execute, which allows you to drop something in, but if you don't have the read there, you can't see what's in that particular folder. So it's really quite useful to use these in combination. And we actually have three groups of these read, write, execute, and they correspond to the three different levels of permission that we have in the system. So when we create a file, we're the owner of that file. We are a member of a group, and we can also assign permissions to different groups for this file. And then there is everyone else. So when we look at those RWX on the file permissions, when we do the ls command, this is what they actually stand for. So D indicates that it's a directory or not. It's just a dash if that isn't set. Then we've got the read permission, write permission, and execute for the owner. So if you change this so that you don't have any read, write, or execute as the owner, you're essentially locking yourself out of that file. And what the Unix system will do, what Linux will do when you try and access a file, it will check the permissions and see if you're a member of the everyone. So do you have a read, write, or execute permission as just a member of the system? Are you a member of a particular group that this file belongs to? Do you have read, write, or execute on there? And it'll respond accordingly. And then as the owner, read, write, and execute as well. Now, these permissions, if we look at them in a bit more detail, so when you have a read permission, you can open and view the contents of a file or directory, because you can have these on directories as well, because everything's a file. That means that you've got permission to read a text file, but you can't write or make changes or append to it in any way. You've only got access to read the content. If you think this is quite useful for media where you don't want it to change, so if you've got a DVD, for example, you might have a read. You can write to the DVD once as the person creating it, but then you can never change that. It's fixed there, and this is quite useful for things like using in court, where you want to make sure that something is authentic and hasn't changed since it was created, and you can do that with read-only media. So the write permission, the W permission, that means you can modify the contents of the file. You can make changes within a directory. So if you just had read to a directory, you wouldn't be able to create new files or change files within that if you haven't got the write permission. So you can see there, for a file, that means you can edit the file, add new content, even delete the file itself. So write is quite an important permission. If you want to make sure people can't delete that, you don't have that included. And for the directory, you've got write permission, lets you create new files, delete existing files within that directory. So that, again, that's quite an important permission to have or not have, as the case may be. Then the execute permission. So this doesn't mean about killing things. This is about running programs. So if you have the execute permission, you can run the file as a program or as a script. So when we're going to write a program and a script in a minute, we'll have to make sure it has that execute permission, otherwise it just won't work. So for a file, this is usually a script or programs, and the file's marked as executable. You can run it directly from the command line. And for directories, the execute permission means you can enter the directory using the cd command and access the files within it. So they've got an example there. If you can execute permission on a script, you can run the script and it will perform whatever program tasks are within that. So who can have these permissions? So permissions are set for these three types of users. So we've got the owner of the file, who has full control over it when they create it. We've got the group, that's assigned to certain permissions to users of that group, and that's useful for collaboration teams. You might have a student or a code club area group. And then others, these are people who are not owners of the group and not in that group in which the file belongs, and they might need some limited access to the file or directory. So interesting, when they was creating the World Wide Web, the others folder permission is where this was residing. So you wouldn't want people changing that from the internet, you just want them to be able to see it as like a read-only. So you'd have that set there. So you can set these permissions, and this is typically how they sort of appear. So you've got like the owner's got read, write, execute. The group which the file belongs has got read and execute, so they can't write to it, but they can run it. And then everyone else has got read access, but they haven't got write or execute on there. Now, what you can do, if we go back to our, I've actually got another terminal we can open up here, and let's go into, if I type that in correctly, of course I've typed it in incorrectly the first time. Let's do that again. Right, so I'm in that same Raspberry Pi. This is just a different way of viewing the contents in this. If I do ls-l, we can see here that dummies.txt that we looked at before, that has, so it's not a directory, it is just a file. As the owner, I've got read and write, but not execute. I can't run the text file because it's not a script. The people who are a member of the same group, which is the Kev group, they can read it, and everyone else can also read it, but they can't modify in any way. So that's the permissions as we see them on individual files. Okay, so if we want to change the permission, we can use this chmod. And we can, the way that we use this is we have this little parameter, so we can change either the user, the group, or the owner permissions, and we can have plus or minus whether we want to set or unset that permission for a particular file. So if we go over to here, and we want to change permissions on that example, for example. So if we want to change the owner of that file, so let's do ch own, so chown, that's changing the owner, and we can change the let's set this to, I think it's the, we'll just find that, chown. Yeah, so you provide the username first. So let's say Alex is going to be the owner of example.txt. And I need to be a super user to do that. So let's just do sudo. If I do ls-l, look, where everything is Kev, because I've created all these files. This one, Alex is now the owner of that file, so I'm no longer the owner of that. I've only got read access to that example.txt. So if I try and, let's try and change that example file. So if I'm just going to echo some text in here into that example.txt, let's see what happens. So it says permission denied, because I'm now just in this, I'm in the Kev group, so I can have read access. So that's how we can change the owner. We can change the owner back to Kev as well, just by doing that chown, because we're still in the sudoers group. We can do this. We do ls-l example.txt. I'm now that owner, so I can now run that hello into the example.txt. If I catalog that example.txt, you can see now it says hello. We've piped that text in there. We'll come back to that in a minute or two. Now, how do we change the permissions? We can change the owner with the chown. Let's change the permissions themselves. So let me just grab this over here. So let's say chmod, which is changing the mode of the file. That's what they call it. And let's say user plus, so the user group, we're going to add the execute. We're going to essentially make example.txt into a script. So if I do that and I do ls-l, you can see it's now turned green, and we've now got that execute ability on our file. So if we wanted to, we could try and run example.txt. It won't like it because it won't actually do anything useful, but if we did example.txt, we do that // it'll try and run it, but hello isn't a command, so it's not going to do anything useful there. But that's how we can do that. We can unset that permission just by changing that plus to a minus, like so. And if we wanted to add the let's change that to a plus, but instead of it being the user, we want to change it to the group. So if I add the execute permission to the group, and then I do that ls command, you can now see that the group now has the execute, and we can also do the same with the everyone else, the others. If I do that there, and then do ls-l, you can now see that others also have that execute. So we can add permissions on all of those three different groups, and we can use the plus and minus to individually set each one. So if we wanted to be really specific, we could say, let's say the group can read, oops, sorry, the G, that should have been G can read. So if we now do ls-l, we can now see that the group has read. Let's change the group to have write as well. So we can say write, and we can even say execute like that. So if I now do that, you can now see on the example.txt, the group, the middle one has read, write, and execute. So we can set these individually. Now it's a bit fiddly typing that out. What people most do is use numbers. Let me show you how this works. So we can change the mode and just pass in some numbers like 755. And these numbers are additive. So execute is 1, write is 2, and read is 4. The reason that read isn't 3 is because 3 could be write and execute, and that get confusing. So having these as like Fibonacci type numbers, this means that we can work out what the permissions are just by adding the permissions that we want and seeing what that number is. So if we wanted read and execute, that'd be 5. If we wanted read and write, that'd be 6. If we wanted write and execute, that'd be 3. If we wanted all of them, then that would be 7. So 755, that means we're adding 4, 2, and 1. We're having all the permissions for the owner. 5 is read and execute for the group, and read and execute for everyone else, for other. So let's try that chmod 755. Let's go back over here. We do change mode 755 for example.txt, and you can see currently it has got read, write, but the owner hasn't got it's not a directory. The owner hasn't got execute, but the group and has full access, and the other has read and execute. So now let's have a look and see how that's changed. So 755 has changed that to be the owner has all the permissions, and everybody else has read and execute permissions. So the 755, once you get your head around that, it makes a bit more sense, a bit easier to work with. Yeah, somebody's just said on the chat there, good old octal. So yes, a nice easy way of working with files. Okay, so we can also change which group simply by using the chown permissions. If I go back in here, I do ch owner, and then I do colon, I can then change which group. So there's an Alex group, for example. We can change, sorry, I need to do sudo, oops, and then now do ls-l. We can now see that the second column has changed, and that's the group. So this is the owner and this is the group. It just shows you an easy way of reading that. Cool, so that's how we work with files. So let's now go to our keynote. So we're now going to be managing software. So if we want to install and uninstall packages on our Raspberry Pi, how do we go about doing that? So let's go back over to our console here, this nice kind of view of it. So for this we will use a package management system. So there's a really cool package management system which is called the Advanced Package Tool, or APT. So let's use APT. Let's go for man APT and see what it tells us about this. So APT provides a high-level command line interface for the package management system. It's intended for an end user as an end-user interface, and it enables some options better suited for an interactive usage by default. So let's quit out of that. So very typically on a system, whenever you want to install a new package, the first thing you do is you update your package list. So let's do that. So we do sudo, because we need to be a super user to do system maintenance, apt, and then update. If you've ever used a Raspberry Pi and the command line, you're probably very, very familiar with this. So what's happening here, this is connecting to a repository. You can see that deb.debian.org, this is Debian underneath, and it's checking the bookworm, which is the release that we're currently in, and it's checking to see what packages are currently released for that, grabbing that file and then installing that on our system. So all our packages are now up to date. Excuse me, and any additional package system, so archive.raspberrypi.com, they've got a Debian repository for bookworm. So all the things that are specific to Raspberry Pi, they're in there as well. So that's really cool. That means now we're confident we're up to date with that repository, that package management. Now we can install lots of different packages. There's a really cool command, let's see if it's installed already, called neofetch. So neofetch isn't available on our system right now. So we do sudo apt install and then neofetch. It's going to check that repository, see that it's there. It's then going to see, this requires some dependent files. So for this to work, you also need to have like image magic, for example, and auto trace and caca utils, whatever that is. So it's saying, do you want to install these? Yes or no? So I'm going to say yes, press return. It's then going to grab all those files. So you'll see them get downloaded. This is what this sort of percentage is. So it's fetched the files and now it's unpacking them and installing them on our system. So it's copying the files from the archive, probably like a zip file or a GZ file if we're on Unix, and then it's installing those files where they should be. Now the good thing about Raspberry Pi 5s, which is what this is running on, it's quite quick to do this for any packages really. It's quite quick to unpackage them and copy them across. Right, so we've now got NeoFetch. If I type in NeoFetch, this is quite cool to have when you log into the system, and it gives us this nice kind of swirly Debian logo, and it tells us all about our system. So Kev at Raspberry Pi, which is my account on the host name. The OS is running Debian GNU Linux 12 Bookworm on the ARC64 architecture. This Raspberry Pi 64-bit. The host is Raspberry Pi 5 Model B revision 1. The kernel is 6.6. Been up an hour because I snagged it just before the show started, so that tells me we've been running about an hour. And we've got 1,566 packages available to install. We're using Bash 5.2. The resolution of this monitor is 1280 by 720. The desktop environment is LXDE running the Pi Wayfire. So this has got the nice effects on there. The window manager is Wayfire. The theme we're using is Pi X Flat. The terminal is LX terminal, and the font is monospace, and the CPU, there's 4 cores running at 2.4 gigahertz, and you can see there we're on the 2 gig Raspberry Pi 5. Cool, so yeah, NeoFetch looks pretty cool, I quite like that. So that's how we install a package. If we want to remove a package, we can do sudo apt remove and then say NeoFetch. And it will say, these are the packages which are no longer required. Would you like to remove them as well? So you can say yes. It's not going to remove some other bits and pieces. There we go, it's removing them. Removing any kind of triggers from the man.db, that's the man database, which has all the manual packages in there, the manual files in there. So we now try and run NeoFetch. It can't find it, it's no longer there. Now, sometimes when we download packages, it kind of keeps them hanging around in like a cache. So that's taking up disk space. We might not want that. So we can do sudo apt auto clean, and we can also do auto remove to tidy that up as well. So it says there's a couple like that caca utils, for example, is kind of hanging around. We can get rid of that, and that will again just give us some disk space back. So if you're running your Raspberry Pi for one of these tiny little SD cards, and it's like an 8 gig one, for example, that might not be very much space at all, and you might it might be important that you're running on minimal disk space. Other things we can do, we can search the apt, so we can do apt search. So if we wanted to find like NeoFetch, for example, we can do apt search NeoFetch, and it's just going to search the local package list. It's not going to go off to the internet for that, sorry. It's just going to search and see, so full text search, NeoFetch stable, 7.1.0.-4, and it shows Linux system information with the distribution logo. So that's a bit of a description about what that package does. Now occasionally you might need to update and then upgrade your system, so you can do sudo apt upgrade, and what that will do is it will check to see are there any packages with newer versions by comparing what's installed with what's available on that package list, and then if you do upgrade it will bring those to the latest version. Sometimes that can break things, most of the time it just works fine and you get the latest patch fixes on that. You can also do -y, and that's a way of saying automatically say yes if it asks a question. So if I wanted to install, let me do the history command again, find that install NeoFetch, that was 204. So if I do exclamation 204 -y, will that work? There we go. So it's basically just installing that package, and the -y just says automatically say yes, install everything, and away we go. It has to install all the packages that we cleared out as well. Cool. So next up then we have We've looked at removing packages, we've looked at installing packages, so that's all good there. So next up then is monitoring system performance. So yes, we want to look at disk space, how much memory we have, and some really cool utilities for doing that. So let's get back over to our Pi, and let's have a look at some cool utilities. So we've got the disk free utility. If I do df, we get this little table of all the different file systems that we have on our system, and we've got how many blocks are being used. Now blocks are useful if you work in binary in the hexadecimal. They're not very useful as a human. So if I do df-h, this is the human readable form. So you can see on there we're using, we have a 1.2 gig, where are we, 1.2 gig available, and we have a 5.3 gig being used. So I think that's probably, we haven't got a very large disk on this system. That's like the block device. So yeah, we probably need to look at having a slightly larger, my guess would be this is like an 8 gig memory card, and we've split it up a little bit. So yeah, 6.8 gig. If you do capital H, you get a slightly different readout. I think that's to do with how it rounds up numbers rather than, because when you have like a gigabyte, it's actually like 1024 megabytes. It's not 1000 megabytes, and that's because of just the way that these things get implemented, because they're all in 8-byte chunks, and they don't round up nicely to sort of decimal numbers. So I don't know if that capital H makes the difference there, but that would make sense to me. Now we can also look at disk usage for folders, so we can see how much space is being taken up by a particular folder. So remember before I copied that dummies guide, that's quite a big file, and I've also downloaded clustered Pi into one of my folders as well. So clustered Pi there. So if I wanted to see how much space that's taking up, I can say disk usage -sh, and then we can do, so the S will say just show me a total, don't show me every single file, that's no use to me, just show me like a summary, and the H is the human readable format, and then we pass it the folder we want to look at, so clustered Pi. So clustered Pi is 100 meg in size. If I jump back a folder again, so we've got kev, we could do the same command, but this time just do it with kev. Oops, so disk usage, sh kev. You can see there I'm using 253 megs of disk space. So you can see there, that's quite useful. If you want to see where your large files are, you can use that command there. Now what about processes that are running in memory? So how well is memory being used? So we can use the top command for this. We type in top, you can see there all the different processes that are running, what account they're running under, like kev or root, and there's a couple other commands in there, like a couple of the accounts in there, such as that avhi. And there's also this process ID number. That'll be quite useful if you ever want to stop some processes forcibly. And you can see there it's sorted by CPU usage, and you can see some other things in here like how much memory. We've got 2 gig total, there's 200 meg of swap, which is like it'll store it onto your flash or hard drive, and then swap some memory in and out just to give it some more virtual memory. And then you can see how much is actually free and all the rest of it. So there's quite a lot of information on there. This is quite an old kind of command, and there's a new version of this which is called htop. So we run that, it looks much more easy to understand. You can see the different cores that we have there. We've got 4 cores, what percentage they're being used. You can see our RAM, so 1.96 gig of RAM, we're using 418 meg, so we can see that with the green and the red. And the swap file, we're not using any swap file at the moment because we've got plenty of actual RAM to use as well. And you can see there we can even move up and down the different processes that are running, and I'll show you how we can kill one of the processes in a second. We can either do that using top, or we can use a command for that. So I'm just going to come out of that, and we're finally just going to look at free. That will tell us how much memory we have and how much is free. Just need to open that window a bit more there so it doesn't wrap around. So there we go, we've got 2 gig of RAM, and we've got 200 of swap file, and we're not using any of that at the moment, so we've got 204 megs free there. So that's the free command. Just some nice quick commands just to check the health of your system. You can even do 3-H, because they're blocks rather than megs. There we go, that's much more easy. So 2 gigs of main memory, 200 megs of swap file, and so on. Cool, so that's managing processes. Let's have a look a bit more about how we can manage some processes proper. So if we type in PS, this will show which processes are currently running. So a bit like top, but it's just showing which ones are running under my account. So PS on its own, I'm running bash, and I've actually just run the PS command, so it caught that. You can see the process ID for that as well. So I've got a little program in here, if I go back into Kev, which is just called PyTest. If I just run PyTest, it doesn't actually do anything. It will just run in a loop. So it's not outputting anything to the screen, it's just looping around and check. It would print something out every second, but it'll get irritating. So I can actually run that in the background by doing the ampersand at the end. So that's now going to run. You can see it's now running under process ID 4188. So if I type in PS, you can see there Python 3 is running as process ID 4188. Now we can get a bit more information than just using PS. We can do PSAUX, and that will give us every single process that's running on the system, and it'll tell us all kinds of information about each one of them. So I'm just scrolling up here. There's just so many things that are running on here at the moment. Give you the percentage of CPU that's being used. It'll even give you the command where this is being run from, which is quite useful if you want to troubleshoot this. But most importantly, it gives you the PID. These are being sorted in process ID order. So that's quite useful if you want to see everything. But if you want to see is a particular thing, running. So I might run that PyTest again. So there's now 2 running in the background. You can see there we've got a little 2. So if I do PSAUX, I'm now going to pipe this into another command. So pipe is that, imagine you can connect pipes together. You can get data coming from one system and pipe that into another process. So the other process we're going to use is called grep, and this is a way of searching for text. So if I want to search for the word Python 3, I can pipe the output of that PSAUX command into grep. Grep is then going to search for Python 3 and only show me lines that contain Python 3. So you can see there's 3 lines. The very bottom one is grep, searching for Python 3. But I've now got the process IDs, 4188, 4192, for each of those. And I can kill them. I can kill 4188. If I now run that, let's try to do the PS command. You can now see we've only got one instance of Python 3, which is that 4192. And I could kill that one as well, 4192. If I do the PS command, I've now not got any Python instances running in the background. Now that's great if you've only got 1 or 2, but if you've got like lots of processes running, that could be quite tedious. So what I'm going to do, I'm just going to run this, say, 5 times or something like that. I do PS, you can now see I've got 5 instances of Python all running that same script but in their own instances. If I want to kill all of them, I can simply type in kill all and then the name of that process, which is Python 3. So it's now killed all 5 of them. If I do PS, they're now no longer running. Now one of the things I did before was that background command. That's quite a useful one. So if you want to run something in the background, so that Python, what I'll do, I'll actually change that. Let's go and edit that PyTest. So you can see there I've commented out this print count is. I'm just going to save this and I'm going to run that again in the background. So Python 3 PyTest. Now if I run that, you can see there it's just counting up in the terminal, but I can't do anything else. I can type things, but it's still running and it's not going to execute them because the shell script hasn't got control. So I've just control C out of that. So if I do the ampersand, that means run this in the background. So it's going to run it in the background, but I can still type in commands and have the shell respond back. So I can do ls-l, it'll go and grab me all the list of everything, like so. But we've still got that count running in the background. So how do I bring that back to the foreground? Well, I can type in FG, and that will bring it back to the foreground, and I can now terminate that. So FG is a way of bringing commands that you've sent to the background back to the foreground. So that's how we can send things back and bring them forward. Okay, let's go back over here. Let's have a look at some networking basics. So one of the most common things you might want to do when you're working with a Raspberry Pi is know what your IP address is. Oops, sorry, it's got the wrong command there. So let's go over here and let's type in ifconfig, interface config this means. If I type that in, we get all this information on here, and it can look quite confusing at first. I'm just going to make this a little bit larger so we can see everything and scroll up. So first of all, we've got this ETH0, so that's the Ethernet 0 interface. So that's the physical connection that we can plug into the Raspberry Pi. If I go to the camera there, that's this black cable that's plugged in there. We also have a Wi-Fi connection on this computer, and we also have a loopback, which is this L0. So there are different protocols that can run on your interface. So you can have IP version 6, and you can also have IP